Hi, in this video we're looking at a word problem that involves differentiating a trigonometric function. This is a problem that's taken from TAN, Applied Calculus for the Managerial Life and Social Sciences. It's in the 7th edition on page 794, but I'm pretty sure it can also be found on other editions. So the problem says the water level in feet in Boston Harbor during a certain 24-hour period is approximated by the formula h of t, which gives the height or the water level as a function of time, and that's equal to 4.8 times the sine of pi over 6 times t minus 10 plus 7.6. And that holds for all values of t between 0 and 24. T equals 0 corresponds to midnight or 12 a.m. And we're asked to find where this function has maximums and minimums, so high tides and low tides, and where the water level is rising or falling, and in the end we want to interpret our results. First of all, since h is differentiable, a maximum or a minimum of h will occur when the tangent line to the curve has a slope of 0. So we need to find where the derivative, which is the slope of the tangent line, is equal to 0. So to differentiate, we will apply to the first term the chain rule. The second term is just a constant, so differentiating it will be pretty easy. It's going to be giving us 0. So for the first part, we can think of the angle pi over 6 times t minus 10. So the expression to which the sine function is applied to as the inner function u. So we want to differentiate 4.8 times the sine of u with respect to t, understanding that u is a function of t. So we apply the chain rule. That gives us 4.8 cos of u times du dt, plus, as I said before, 0, because 7.6 is just a constant. So replacing u by what it is, we get this. And differentiating the inner function, pi over 6 t minus 10, gives us pi over 6 times the derivative of t minus 10, which is 1 minus 0. So overall, regrouping our constants together, we get 4.8 times pi over 6 times the cosine of pi over 6 times t minus 10. And this is what we need to equate to 0 in order to find where the function has maximums and minimums. So if we think of the inner function pi over 6 t minus 10 as an angle, as theta, we need to find where the values of theta for which the cosine is equal to 0. So for this, we need to go and look at the unit circle and figure out the angles where the cosine is equal to 0. Now the cosine corresponds to the x-coordinate for a point on the unit circle. For example, at pi over 2, we can see that one of the x-coordinate is 0, and at pi over 2, therefore, the cosine is equal to 0. But we could also look at 3 pi over 2, and we get the same result. There's also a cosine of 0. Now, we have to remember that angles here are given so that we are rotating counterclockwise. But if we rotate clockwise, we get negative angles. So 3 pi over 2 is also coterminal with an angle of minus pi over 2. So actually, we get a cosine of 0 at plus or minus pi over 2. But we also get a cosine value of 0 at plus or minus 3 pi over 2. And so on. So and plus or minus 5 pi over 2. So we need to look at all of those angles. Those are all possible angles where the cosine is equal to 0. So this explains why all the angles we're looking for are contained in a set. Now we're going to replace theta by what it is, pi over 6 times t minus 10. So this means that pi over 6 times t minus 10 is contained in the set plus or minus pi over 2, plus or minus 3 pi over 2, and so on. So we need to isolate t on the left-hand side. So if we multiply everything by 6 over pi, we get that t minus 10 is contained in the set 6 pi over 2 pi, plus or minus, then plus or minus 3 times 6 pi over 2 pi, then plus or minus 5 times 6 pi over 2 pi. And if we simplify this, we just get that t minus 10 is contained in the set plus or minus 3, plus or minus 9, plus or minus 15. And adding 10 now gives us that t is contained in the set minus 5, 1, 7, 13, 19, 25, and of course there's a whole bunch of other numbers to the left of minus 5 and to the right of 25, but we only care about those that are between 0 and 24 because we only care about what's happening during a full day. So we're only going to care about the values of t 1, 7, 13, and 19. So those are possible values of t where we're likely to get maximum and minimums. So the next step is to replace those values of t in our function h and check and check what kind of values we get from those, and see which ones are minimums and which ones are maximums. So if we replace t by 1, so we get 4.8 sine of pi over 6 times 1 minus 10. So I've replaced t by 1 plus 7.6. So the inner expression is minus 9 pi over 6. That's the same as minus 3 pi over 2. So at minus 3 pi over 2, remember that this means that we get this angle by turning clockwise. So 3 pi over 2 is going to be coterminal with pi over 2. So the sine is the y-coordinate at that point, which is 1. So we get that h of 1 is 4.8 times 1 plus 7.6, and that gives us 12.4 feet. H of 7 is obtained in a similar fashion, so we replace t by 7. So we get 4.8 sine of 7 minus 10, which is minus 3 pi over 6, plus 7.6. Now minus 3 pi over 6 is minus pi over 2. That's going to be coterminal with 3 pi over 2, and the y-coordinate at that point is minus 1. So we get minus 4.8 plus 7.6, which is 2.8 feet. So this is going to be one of the minimums. With 13 and 19, we can repeat the same process. At 13, we get an angle of 3 pi over 6, that's pi over 2, which gives a sine value of 1. And at 19, we get 9 pi over 6, that's 3 pi over 2, that gives us a sine value of negative 1. And we again get 12.4 feet at when t is 13, so that's at 1 p.m. And at t equals 19, which is 7 p.m., we get a minimum of 2.8. So we get 2 maximums and 2 minimums, basically. Now, if we put those points on a graph, we see that we have, as expected, 2 maximums and 2 minimums. And because this is a sine curve, it's going to oscillate between those maximums and minimums. So let's add that curve. We can see from this that the water level is going to be rising just at the beginning, between 12 a.m. and 1 a.m. It rises again between 7 a.m. and 1 p.m. It rises also at the end between 7 p.m. and 12 a.m. Otherwise, it's going to be falling. So the interpretation that we could give to this is that we observe 2 high tides and 2 low tides. And that's normal. This is actually a good model because this is what usually happens in the world when there's water rising and then up and down due to the tides. You typically have two tides per day. And this is what the model predicts. And it also explains why a sine curve or a model that oscillates and that's cyclic is a good model here, because this pattern is going to repeat itself day after day. So what I wrote here as an interpretation is that, as in many places in the world, Boston Harbor experiences two tides per day. Twice per day the tides are high at 12.4 feet and twice per day low at 12.8 feet. And this explains the cyclic nature of the model. Thanks for watching.